So here are the notes for 1.11, example 4, and example 5. So you have already seen how to solve systems of equations using the algebraic method. That's basically using substitution. But sometimes the substitution way doesn't work. As you can kind of see in example 5, right, we have some decimals. Well, we can't really factor decimals. We can, but it does become very difficult. So another way in order to solve systems of equations are using the graphing calculators. And what we're going to do is use our intersection feature, which we have done before. Remember when we did intersection feature, when we did solving systems of linear equations, that was chapter 0.5. We used the intersection feature to find where the two linear functions intersected. So we're going to do the same thing here. Now, in order to put this into our graphing calculator, we have to set each of our equations so that it's y equals. So here, we might have to move some things so we can do that. So we're going to try example 4 first, then I'll have you kind of try example 5 on your own. Okay, so notice here that both of them, they're not already solved for y, so we have to do that for both. So look here. So it looks like we're going to subtract the 3 on one side and the x squared. So I'm going to bring this one down here. So we have x squared minus 7y plus 3 equals 0. I'm going to subtract x squared and the 3 to the other side. So now I have negative 7y equals negative x squared minus 3. Now it's okay to have a negative x squared here because we still have to divide by our negatives, so that'll make it a nice positive. So we're going to divide each term by 7, or negative 7. So we have y equals, so when we divide this by a negative, we have two negatives, that makes it a positive. So now I have 1 over 7 times x squared. And then negative 3 divided by negative 7, that'll make it plus 3 over 7. Now, when we plug this into our calculator, we don't get finite decimals. So what we want to do is we want to keep both of these as fractions. Don't change them to decimals, or you will not get the correct answer at the end. Okay, so we solved for our first equation. Now we're going to solve for our second equation. Now, what I'm going to do is move the 2x over. So I'll change colors for this. We have 2x minus y equals 3. I'm going to move the 2x over, so now we have negative y equals negative 2x plus 3. And remember, we can't have a negative y, so we will either have to multiply or divide by a negative 1. Both will get us to the same answer. So we have y equals positive 2x minus 3. So now we're going to set both of these equations into our graphing calculators here. And remember, if I'm ever going too fast, all you have to do is pause the video so you can get all this written down here. Okay, now we're going to go ahead and go to our graphing calculators. Now, to plug in our values, we're going to go to the y equals. So our y1, as we said before, we're going to have our 1/2 or 1 over 7x squared plus 3 over 7. Now, using a graphing calculator, you can press alpha y equals to get a fraction. And here I can put 1, now down arrow to get your 7. And then I can use my x squared. So remember the x that's right next to our alpha, so we do x and then a squared. Then we do that again, alpha y equals, so we can get our 3/7. So I do plus, and then alpha y equals, press enter, so we can get our fraction here. 3, down arrow to get your 7. Now we got to put our y2, so I'm going to down arrow for that. This one's a little bit easier. All we got to do is put 2x minus 3. Make sure you use the minus button. If you don't, it's going to say an error or it will not work. Okay, now what we're going to do is press the graph key so we can see where it intersects. Now notice that we will have a quadratic and a linear, and that means they probably will intersect at 2 places. So there's our quadratic, and then there's our linear. Now, if we look here, notice that our linear quadratic only intersect at one place. But we know that we should get two solutions. Well, that might mean that we will have to actually change our window so we can see the other intersection. Now, changing the window, we're going to go to the window button. And notice that it seems like our quadratic and linear, they intersect somewhere up here. So we will have to change our x on the positive sign, so make it bigger, and then the y's, make those bigger as well. So now we're going to go to window. Now, to know how big to make it, this is kind of just a trial and error process. So let's just say we change our x max to 20. With that, I'm going to change my scale to 5s, just because I don't like to see all those little tick marks. And I'm going to change my y max to 20 as well, and then change my scale to 5. If you'd rather change your scale to 2, you can do that as well. That works perfectly. Okay, now I'm going to press graph again and see if this works. If not, we just kind of readjust again. So there's our quadratic. We kind of can see it intersect, but it looks like we can see definitely on the x-axis where it intersects, but not on the y. So that means we do have to change our window just one more time so we can maybe make our y window a little bit larger. So I'm going to go back to the window button. I'm going to go down to my y max because we want to make that bigger. I'm going to change that to 30. Now, as I said before, to know what to make your window, it is just a trial and error process. If you still can't see it, either make it bigger or smaller along the x or y axis. So let's go ahead. Since I changed my y max to 30, keeping everything else the same, I'm going to graph again. So there's our quadratic. There we go. Now we figured out where crosses are, or where they intersect, and they intersect twice. So now what we're going to do is we're going to press second and trace. We're going to go to number 5, our intersect, because we're trying to figure out where the quadratic and the linear functions intersect. We're going to press enter. Now we will have to do this twice because we have two intersections. So I have my cursor. Now, because we have two different intersections, you just want to get your cursor close enough to the one that you're finding. So let's find the one that's on this left-hand side here. Okay, so I'm just going to move my cursor, remember, using the left arrow, so it's just a little bit closer to that intersection point. So I'm going to press enter. Now the second cursor is already on our line, and it looks like it's close enough here to our point. So I'm going to press enter again. Now don't forget, every single time we've done these graphing calculator portions, we always have a guess question mark. Make sure you press enter one last time to get your final answer, because if you don't, you're going to get the wrong answer. Okay, so it looks like that the intersection, one of them is going to be 2, 1. So for one of our answers, we're going to write 2, 1. Now remember, when we write the intersections, we write them as an ordered pair. Please do not forget that. Okay, so there's one of our answers. Now we're going to do the same exact thing to find the other intersection. So I'm going to go back to my graphing calculator. And what I'm going to do is I'm going to go back to second, the trace button, go to number 5. Now, what I want to do is find the intersection up here. To do that, I'm going to bring my cursor closer to the right-hand side of our intersection. That means I'm going to use my right-hand arrow to just move slightly over. Once I've done that, I'm going to press enter. And then on the second curve, that just means basically your linear function. It should be already close enough. So you just press enter again. And then when it says guess question mark, remember to press enter the third and last time. And it looks like that our intersection here is 12, 21. So we're going to write that as an ordered pair. There we go. Now I'm also going to draw a graph just to show what this looks like here. And it's really just going to be a sketch. It's not going to be anything really pretty here. So I got my boom. Now we do our quadratic, and then we do our linear. I'm going to go back so I can remember what that linear looked like. There we go. So we went through the bottom, up. There we go. And then these two would be our intersection points. Okay. So basically that's what you would have to do. Make sure that you change both your equations into the y equals. Then put your answers as ordered pairs, like so. And then if they do ask you to sketch a graph of basically your quadratic and your linear, make sure you do that. Okay, so example 5, I would like you guys to go ahead and try this on your own. So don't forget to change both of them so it's y equals, and then using the intersect feature to find those both intersections. So go ahead and pause the video so you can try this on your own. And then if you get stuck anywhere, go ahead and play the video so you can see where you're going wrong. Okay, hopefully you paused the video to try the problem. We're going to go ahead and do it together so you guys got the correct answer and see if you got the correct answer. Okay, step 1 is to change both our equations so it's y equals. So the first one, we got to change x squared plus 6y minus 1 equals 0. So we will have to change that. I'm going to rewrite it. Okay, so I'm going to move the x squared and the negative 1 over. So now I have 6y equals negative x squared, and then we have a plus 1. Our last thing is to divide each term by 6. So when we do that, we get y equals negative 1/6 x squared plus 1/6. Now it's okay for this time to have a negative x squared because we're plugging it into our graphing calculator. The only time we don't want a negative variable squared is when we're actually doing the algebraic ways substitution, because it makes factoring harder to do that. Okay, now we have to do our second one. So here, solve for x, but remember to plug into the graphing calculator, we got to solve for y. So we're going to move the 2.6 over to the other side, so that'll make it negative, and then divide each term by negative 0.4y. Okay, I'm going to go ahead and do that. So we had x equals negative 0.4y, and then plus 2.6. Remember, we're going to move that over, so we now have x minus 2.6 equals negative 0.4y. And then we divide each term by the negative 0.4y. So now we have, I'm going to rewrite this, so we have y on the left-hand side. So now what we have is negative 1 over 0.4 x, and then plus 2.6 over 0.4. Now usually I would say, okay, do not leave this, right, when you have a fraction and a decimal, but we are just plugging it into the graphing calculator, so it's okay to do it here. So we're going to plug both of these into our graphing calculator, into the y equals. So make sure we go back to y equals. We're going to clear both of our example 4. So the first one I'm going to have, I'm going to do my alpha y equals to make a fraction, right? So alpha y equals, and then press enter. So here, make sure that we have a negative. So I need to make sure I have a negative in front. Use the negative key, because if you don't, you're going to get that one wrong. So I put 1 over 6, and then right arrow over, and then I do x squared. Then I'll have the plus 1/6, so plus, and then once again I do alpha y equals. Do number 1 for a fraction, have 1, down arrow to put your 6 in. Now down arrow to y2 so we can do the other one. So for that one, we are going to have, once again, a negative, so make sure you use negative. I'm going to do alpha y equals, And then once again, do the fractions. So it'll be 1 over 0.4. Arrow over to put the x. And then we're going to have our plus here. So we'll have plus, and then once again, alpha y equals, enter. We'll have 2.6 all over 0.4. So now that we got that, we're going to go ahead, we're going to press zoom because we're going to see if we can put this back into standard form so we can see where the quadratic and the linear intersect. So I'm going to go zoom and then Z standard. That actually gets your graph back into standard form. Okay, so let's look here. So we see one intersection, but we don't see the other. So just like we did before, we will have to change our window. Now it seems like we will have to make our x values bigger, but because the y values, it seems like it's intersecting all the way down here, we will have to make that smaller. Okay, so go more into the negative values. So to change our window, we're going to go back to window. So as I said, for our max, let's go ahead and change it to 20. And I'm going to change my scale once again to 5. If you rather keep it as 2, you can do that as well. Now, I actually have to change my y minimum, because remember the graph was going down into the negative values for the y. So I'm going to make this negative 20, so make sure you do negative 20. And once again, I'm going to change my scales into 5. So let's see if this window works. If not, we can always change it to make sure it does work. Okay, so it seems like we might have to change our y values once again. X looks perfect because we can see where it probably crosses at the x, but the y we're not very sure. So I'm going to change it probably to negative 30. Let's see if that works. So I'm going to go back to window. I'm going to go back to my y minimum, so that's the min here, and change that to negative 30. Remember, this is once again a trial and error process, seeing where it intersects. Well, it seems like negative 30 did the trick because now I can see both intersections. So now what I'm going to do is I'm going to go to second trace and go to number 5 for intersect. So let's go ahead and find the intersection, the uppermost intersection. Make sure your cursor is close enough to it so we can get the best reading. So I press enter because it's already on our first curve. Then I can press enter again because our cursor is now on our second function. And then remember, don't forget, press enter again for your guess. There we go. So it looks like here, using the graphing calculator was a better option because we do get decimals as our answers. Let's go ahead, we can just round our decimals to 2 decimal places. So it looks like for our first intersection, we have 3.23 and negative 1.57. Now let's make sure we write that as an ordered pair. So I'm going to scroll down so I can write my answers here. So first solution set will be 3.23, comma, negative 1.57. And don't forget to write your answers as ordered pairs because you're finding the point where the two graphs intersect. Okay, now we're going to do the same thing to find the other intersection. So we're going to go to second trace, number 5 for intersect. Now I do need to get my cursor down closer to our second intersection point. So to do that, I'm going to right arrow. Remember, you can only use right and left arrows to move the cursor. I'm going to press enter. Your second curve is just going to basically be this linear. Okay, press enter again, and then press enter one more time. And once again, we do get decimals. And let's go ahead and round to 2 decimal places like we did before. So this other intersection is 11.77, negative 22.93. So our 2 answers are decimals. So then that definitely tells us that we would have had to use a graphing calculator to find our answer. And I'm going to go ahead and just sketch a graph of what our intersection looked like, just in case if you have to do that for the homework or if it does ask you, please do it. Okay, so our quadratic was opening down. I know this does not look very good as a quadratic, but of course it's just a sketch. I'm going to go back to my graphing calculator so I can kind of see what the linear equation looks like. So it's going down and it intersects twice. So I'll go ahead and do that. So 1 and 2. And that looks good enough since it's just a sketch. So these are the two places where the linear and the quadratic intersected. So if you have any further questions, make sure you either email me, come in before or after school. And remember, some of these you will have to use the substitution way, and the other ones you will have to use a graphing calculator.